Hi, this is our multimeter circuit code. In this circuit, we're using an LCD and an IR remote. Right here, we have a little overview of the code. And these two lines are for our LCD libraries and the IR library. This line is for the pins we use for the LCD. This line is to set up the receiver. We're using pin 2, and this line is to decode the results. Right here, we have our variables for the ohm meter. This is to read the voltage for R1. R1 being our unknown resistor, R2 being our known resistor. These are the pins we used for R1. 15, 16, 17, 18, which would be A1, A2, A3, and A4 if it would be analog pins. And then this is their corresponding resistor values. Right here are the units. And these are the variables for the capacitor meter. At analog pin A0, we read the value for the capacitor. At pin 5, we have a resistor that's charging the capacitor. And pin 6, we have a resistor that will discharge the capacitor. And right here, this is used to calculate the time the capacitor takes to charge. We're using a 2 meg ohm resistor, so we can read small and large capacitor values. And float C is used to store the capacitor value. And right here, it's for the units. And these are the variables used for the inductance meter. The pulse, that which stores the wavelength, frequency, period, and we're using a capacitor value of 2 microfarads. And this is for the inductance. And then FP2 stands for the 4 times pi squared, which is used to calculate inductance. And the following is for our setup. Here we begin the serial monitor. We just use this to check the inductor to make sure it's giving us valid inductor values. This is the LCD size with 16 columns and 2 rows. We display a message for 2 seconds, hear the screen, and give the user instructions to pick the ohm meter using the up button on the IR remote, the down button for the capacitor meter, and the pause button for the inductor meter. And right here, we enable the receiver. Right here in the loop, once a valid button is chosen, being up, down, or pause, it takes you to its corresponding meter code. Right here, if we choose a resistor meter, it clears the screen and asks the user to pick 1, 2, or 3 for R2 values, which is the known resistor. And then the resistors are put as inputs, so no voltage goes through. And once a pin is selected, it's set to output and low, so it allows voltage to go through. And once the voltage is through, we calculate the unknown resistance of R1. And then we display the R1 value and the units. If the unknown value is larger than the known value, it asks the user to increase the scale. If not, it prints out the unknown resistance value. And this is our capacitor meter code. Once this mode is chosen, the charge resistor is set as output and ground, so no voltage is applied initially. We then begin a loop that charges the capacitor continuously by setting the charge resistor to high so voltage goes through into the capacitor. Here we start taking the time, and using tau, we represent the time to calculate how long it takes the capacitor to charge. Right here, the capacitor is calculated using the time it took to charge divided by the resistor. Then right here we put the default units, which is microfarads. If capacitor value is less than 1 microfarad, we turn it into a nanofarad. Right here we display the capacitance value. And after that is displayed for 3 seconds, we start discharging the capacitor value and it starts all over again. Right here we have the inductance meter code. Here we'll be sending up the pins we'll be using for the inductance meter. Pin 4 is going to wait for to receive a signal from the comparator, which will be used to measure a pulse. And then this controls the charge resistor, which is 110 ohms. We clear the screen and print inductance. And then right here, we start charging the resistor, which gives us the top of our sine wave. It gives it some time to charge, and then we stop charging the resistor to give us the bottom of our sine wave. And then the comparator chip will turn the sine wave into a square wave, so the Arduino board can read the results better. And right here, we put the pulse in the serial monitor to make sure we're getting a valid input. We get a valid pulse, then we proceed to get our inductance value. And this 1.65 is due to a small interference loss from the IR resistor and the chip. We saw that it gave us half our actual value, a little bit less than half, which this number is used to make up for. And after that, we print our inductance value onto the screen and delay for a couple of seconds before charging the inductor again. And that's it. Thank you.